Greetings, biology learners. We have one more piece of evidence that we need to discuss or practice before you can complete your graphic organizer and start writing your Target 9 claim evidence reasoning. So hopefully you've turned to packet page 63 and you have already actively read, which means read and annotate, the instructions and the introduction on packet page 63. So hopefully you've done that. So if you have done that, I'm going to quickly show you how you go about doing that and provide you with some quick little hints. And then you can go back to the today's slideshow slide to check your work and then complete your molecular biologist graphic organizer. So once you've read the directions, basically what it tells you to do is look at the nucleotide sequence for the gene beta hemoglobin, and you're going to compare the 4 primates, the chimpanzee, gorilla, human, and orangutan. You're going to compare their nucleotide sequences. Now this gene was so long that I started writing the gene sequences at the top, and we go all the way across the top from left to right, and then we continue the gene sequence in the middle row, and there's still not enough room, so we have to continue and put the last third of the gene sequence at the very bottom. So that whole thing, 180 nucleotides, is approximately the length of the beta hemoglobin gene. So what we're going to do is compare human sequence to the 3 other primates, to the gorilla, the chimpanzee, and the orangutan. So what you're doing is you're going to start there at the human, and you have a highlighter in your hand, and you're going to look and see a T, and then you're going to compare up and down. Does everybody have a T? If they do, you leave it alone. If they don't have the same nucleotide, such as in the second position, humans have an A, but gorillas have a C, so you're going to highlight the C. That's really hard to do while I'm trying to make a video. Okay, so then you keep going. The 3rd nucleotide is the same. The 4th nucleotide is actually a deletion, but the orangutan actually has that nucleotide, so I would highlight the C because that's different from humans. And then you just keep going all the way across and compare and compare and compare. And don't just get stuck in a rut. Make sure that you're actually comparing gorilla and chimpanzee to human as well, because eventually you'll see a difference. Not a lot, but you'll see a few. So if you do it correctly and you've done the first sequence, or the first third of the gene sequence, then what you should see is something that looks like this. And what I would suggest you do at this point is count up the number of differences that you have between the human and the chimpanzee, between the human and the gorilla gene sequence, and the human and the orangutan nucleotide sequence. So for the chimpanzee, you can see I have 0 differences. So I'm going to write a 0 right there. There's no differences. Between the human and the gorilla, there is 1 difference. So I'm going to write a 1 there. Obviously, human, I'm not going to compare the human to the human, so there's just no number there. And the orangutan, if you count up all of those nucleotides that were highlighted, you should see 35 differences. So hopefully that's what you got. Go ahead and do that now. And when you're done, then continue that same process for this middle third of the gene and for the final third of the gene. Take your numbers that you write on the far right hand side, add them all up for each species, and then you're going to put that information into your packet at the bottom of page 63. So those are the number of differences compared to humans, right? So compared to humans. Then you're going to do the calculations as you see the formulas for the calculations in the middle box column, and then the calculations for the box. The box is on the far right hand side, and then once you've done that, then you should be able to answer the analysis questions. Dun, dun, dun. And so then you're going to just kind of think about what you see based on the data. What can you infer based on the data? And then if we give you some data about gibbons, what can you say about those? And then Once you've answered all of these questions, you should be able to make the cladogram at the bottom of page 60 in your packet. So I have every confidence that you'll do great, and then use the remaining class time wisely to work on your graphic organizer or start working on your CER. I will see you on Friday. I will be available Friday morning if you have any last minute questions before the test. Good luck and go learn. Bye.